1.1. So A is the set of human beings and X and Y work at the same place. So obviously if we check X and X belongs to R, that means X and X work at the same place. So that is true. We have to check here in this type of question, we have to check that this is true or not. This is true. So therefore, R is reflective. Means we can write like this. And the second is symmetric. So for symmetric, let X, Y belongs to R. Implies that the condition X and Y work at the same place, because this is the definition, work at the same place. Can we write X and Y instead of XY? Can we write Y and X? Will it make any difference? Yes, we can write. We can write Y and X work at the same place. The relation will not affect if we write X or X and Y or Y or and X. But this will show that Y X also belongs to R. So hence prove that therefore R is symmetric. R is symmetric. Similarly for transitive also we have to write like this only. So for transitive, third is transitive. So for transitive, we have to take two things. Let X, Y belongs to R. Let X, Y belongs to R implies that X and Y work at the same place. And Y, Z also belongs to R implies that Y and Z work at the same place. That means all the three human beings work at the same place. So we can say that this implies that X and Z work at the same place, work at the same place. Therefore, which shows that X Z sorry, X Z also work at the same place. X Z belongs to R, or X Y and Z belongs to, or X Y and Z belongs to A. Here also you can write X Y belongs to X Y. This one also you should write X Y belongs to A, and here you can write for all X belongs to R. So whenever it is transitive, symmetric, and whenever it is reflexive, symmetric, and transitive, we can say that the relation R. Therefore, we can say that R is an equivalence relation. R is an equivalence relation. So sometimes we have to do like this. Show that the relation R in the set R of real numbers. Means set A जो है, the set A is the set of real numbers. You should remember set A is the DNA of this. So we should first check what is set A, or it is denoted by bold R here because there are two R's, one for relation, one is for real number. So that's why they have used the two R's. This one R for set and this one R is for relation. And relation R is defined as R is the relation AB. AB are real numbers such that A is less than equal to B square. A is less than equal to B square is neither reflexive nor symmetric nor transitive. As I told you, we have to show that it is not reflexive. So for not reflexive, one example, we need one example to show that it is not reflexive. So all are real numbers, we can take any number. So we have to think over it, what example can be taken. So you know that if we take 1, 1, 2, 2, 1, 2, 1, 1, if you take 1, 1, so 1 square is equal to 1. If you take 2, so 2 square is always greater than 1. So we cannot take the whole numbers. Real numbers contains all the numbers. Then we go to check the numbers in fraction like 1 by 2. Because 1 by 2, if you write the square of 1 by 2, it will become 1 by 4. Okay. So 1 by 2 is not less than 1 by 4. It will not follow. We have to check it should not follow. This will be followed here. All for whole numbers, it will follow. But when we write 1 by 2 or any other example that you can see, so we can observe that for reflexivity, we can say that we could write like this also. It is up to us to explain. Or we observe that one example that 1 by 2 is less than equal to 1 by 2 square is not true. Is not true. That is, we can say that is 1 by 2, 1 by 2 1 by 2, 1 by 2 does not belong to R since it is not satisfying the given relation. So R is therefore R is not reflective. True. Then second condition is symmetric. For symmetric, again we have to find where we can get the square. If you check any negative number with a positive number, so actually we have to check whether A is less than equal to B square or then B must be less than equal to A square, which is not possible for negative number. For example, minus 1. If we will take minus 1, so minus 1 and 3. So minus 1 is less than 3 square. But 3 minus 1 and 3, we are taking minus 1 and 3. So A is less than B. But if we write 3, 3 is not less than equal to minus 1 square because 3 is greater than equal to 1 square is 1. Okay. So minus 1 and 3. We will take minus 1 and 3. So since we can write like this also, since minus 1, 3 belongs to R, that is minus 1 is less than equal to 3 square, but 3 minus 1 does not belong to R, as 3 square is not less than equal to, as 3 is not less than equal to, the left side we have to take without square, as 3 is not less than equal to minus 1 square. Okay, so this shows that R is, therefore R is not symmetric. So we have to, sometimes we have to remember the number which will not show. There are two questions, I think A is less than equal to B cube is also there. And this one, yes, A is less than equal to B cube, question number 5. There also we have to remember some numbers for proving it. Similarly, for transitivity, three numbers we have to take. So 2 minus 3. 2 minus 3 belongs to R, belongs to R. That means 2 is less than equal to minus 3 square, obviously. And minus 3 and 1, 2 minus 3 and then minus 3 and 1, that also belongs to R, because minus 3 is less than equal to 1 square. Okay, but 2 and 1 will not belong to R, as 2 is not less than equal to 1 square. True. Therefore, R is not transitive. R is not transitive. So, like this, when it is not transitive, we have to remember some numbers which will not follow the given condition. Question number 5 of exercise. Question number 5 of exercise 1.1. Reflexivity. Here, again, you should check first A is the set of real numbers, means all numbers are included here. Set of all real numbers. If it is written R here, written capital R, this capital R shows that it is real number set. So we should write A is the set of all real numbers, and R is the relation which is defined as A is less than equal to B cube. Check whether it is reflective, symmetric, or transitive. So again, we have to find some numbers which will not satisfy. If we are finding, then it is not reflective. Reflective. So 1 1, we can take 1 and 1 again. Okay, okay. 1 minute. Okay, so we are taking question number 5, exercise 1.1. A is the, here A is the set of all real numbers. Here it is given capital R. Capital R means bold R is written for real numbers. So this is the set of real numbers. The relation is defined on the set of real numbers and it is defined by A is less than equal to B cube. So again, we have to find the numbers which will not satisfy here. So since if we take let 1 by 2, 1 by 2 belongs to R, then we can write in any way, then 1 by 2 is not less than equal to 1 by 2 cube. Therefore, 1 by 2, 1 by 2 does not belong to R. Like this we can write, or we can write since 1 by 2 1 by 2 belongs to R, implies that 1 by 2 is not less than equal to 1 by 2 cube. Therefore, R is not reflective. R is not reflective. Second, symmetric. Symmetric, again we have to find some examples. So here you have to work on it and find some examples like let 3 and 3 by 2 and 3 by 2 and 6 by 5 both belongs to R. As why they belongs to R, as 3 is less than 3 by 2 square. How will you check? 3 is a 9, 2 is a 4, 3 4 is a 4, 3 is a 12. The cube, sorry. This is cube. So 3 is a 9, 3 is a 27. How will you check whether it is applicable or not? You will write like this: 3 is a 9, 3 is a 27, 2 to the 4 to the 8, and 8 will multiply the 8 3 the 24. Left side is 24, right side is 27. That is followed. Similarly, 3 by 2 will be less than equal to 6 by 5 cube. This also you can check. You can check 3 by 2 whether less than equal to 6 into 6 into 6, multiply 6 into 6 into 6 and 5 into 5 into 5 125, 6 into 6 into 6 36 into 6 6 is a 36, 6 3 is a 18, 216. So 125, when you multiply 125 into 3 and 216 into 2, so 3 5 is a 15, 3 2 is a 6 7, 375, and here you will get 432. So 375 is less than, so true. Okay, so uh, I have taken directly. Sorry, first you take actually symmetric, but okay, no problem. I have taken transitive first. Then we can check 3 and 6 by 5. Whether 3 and 6 by 5 belongs to R or not? No, it will not belong to R, as 3 is, you can write opposite greater than, as 3 is greater than 6 by 5 cube. 3 is greater than 6 by 5 cube. You can check this also. Okay. So therefore, R is not transitive. Then third, first you write symmetric and then transitive. And symmetric, for symmetrical 1, 2, let 1, 2 belongs to R, implies that 1 is, as 1 is less than 2 cube, correct? But 2, 1 will not belong to R, as 2 cube is greater than 1. So we'll write 1, 2. So 2, 1. A is less than equal to p cube. The relation is A is less than equal to p cube. Here A is 1. So 1 is less than equal to 2 cube. But when you write 2 here, I have changed the way of writing. Okay. Either you can write this, or you can say that 2 is not less than 1 cube. 2 is greater than 1 cube. So both ways, either you write this way or this way, same thing. So then, therefore, R is not symmetric. Okay.